All right, so we are starting lesson 6.3. So this first part, we're talking about exponential patterns. So when we talked a lot about linear patterns in the first chapter, which we'll talk about again in a second, not the first chapter, first half of the book. Then we move to exponential patterns, which we'll talk about in just a second. But to get you thinking along the right lines, you do not have to write this part down. I want you to listen to me. Let's say a rich stranger on the street says to you, I'll give you a choice. Do not have to write this down. I'm going to write it down so you can just have it to look at. I will either give you $1,000 every day this month, or today I'll give you one penny, but then every day I will double it. So tomorrow you're going to get how many pennies? Right. So that would be 2 cents. And the next day you're going to get what? 4 cents. Okay. So my question is, for the rest of the month. Okay. So let's say, just for the sake of it, our month has 30 days. Okay. 30 days in this month. What are you going to take? How many people are going to take the $1,000? Give me the $1,000. Okay? Everybody else going to take the pennies. Wait. Is that...
Wait, the pennies? And then it doubles.
It doubles.
Everything you earn doubles. 100 will go to 200.
Besides on the last day.
Oh, if you have $1,000.
I'm still taking this.
Okay, so let's talk about this. So let's say, again, like I said, you don't have to write this down. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, get out your calculator. Let's see who's making the right choices here. So I'm going to show you something that your calculator does that's super handy. Okay, so I want you to start with 0.01, put it in your calculator. That's our 1 penny. And hit enter. Okay, it's just going to tell you, yeah, that's 0.01. This is a cool thing on your calculator. You want to multiply that times 2. Just hit times, it should come up with answer 2. And then hit enter. Now, what this does, this is like making a mini computer program in your calculator. It will take whatever thing that you have here and it will multiply it times 2, which is what we want it to do, right? So the next day of the month, you're going to hit enter, 4 cents. Okay. So you're going to hit enter again, and you're going to get how many pennies on day 4? 8. Okay. How many on 5? Okay. How many on 6? 32. How many on 7? Okay. 8. $1.28, right? Okay. What's next? $2.56. Next. Okay, next. Okay, what's next? Abby, turn around. 2048. Next one. Okay, day 14.
81.92.
Okay, 15.
163 is 84.
Okay, 16.
327.68.
Okay, now I have a question. You penny people, are you concerned about yourself right now?
No.
What does the other group have at this point?
30,000.
No, this point.
Probably nothing.
16,000.
16,000 because it's $1,000 a day. At this point, they're looking pretty good, right? Okay, 17. How much? 50. You said 55.26.
Yeah.
Okay.
36.
How about 18?
13.10.72.
Okay. Now we're talking about, we're even-ish, right? They got $1,000, you got $1,300. Okay. They're still ahead. They still have 18,000, and this does not add up to 18,000. Okay. How about 19?
26, 21, 44.
Okay, 20.
52, 42, 88,
Okay, 21,
10, 48, 5, 76,
22,
20, 97, 1, 52,
23.
41, 94, 3, 0, 4.
Okay, now pause a second. How much is this group going to make total?
30,000.
You just got that, more than that on day 23. If you were patient, look what happens. Okay, I'm not writing them all down, but so hit enter for 24. Should have 83 something. 25, 26, 27, 28, 29, and 30. We got big numbers here, right? 24, 25, 26, 27, 28, 29, 30.
Then we're on the building.
Okay, so I believe you have 5368709.2.
No, that's for 29.
Are you sure?
For 30 you get
Hang on. 23,
30 or
24, 25, 26, 27, 28, 29. No, this is 30. You didn't count right. Okay. Anyway, literally, let's be real. You just got $5 million. What does the other group have? 30,000. Okay. So you just have to, like in this situation, you just have to be patient through the small numbers and eventually they get really large. Okay. This is an exponential situation because remember that an exponent, we talked about this the other day. You don't have to write this down either. But you remember, like if we have an exponent, we said this is the exponent and it means repeated what? Repeated multiplication. What number are we multiplying here? Multiplying by 2 every time. When you have an exponential pattern, it grows slow at first and then it grows really fast. Okay, so an exponential pattern. So that's what we're talking about. Now you can start writing. Okay, so what we're doing, I want to take us back like a mental field trip into like chapter 3 and chapter 4. Really, can't remember which one it was, but you should be able to finish the pattern. Okay, so you should be able to give me, let's go the next two numbers. 14, 17. Okay, because what's the pattern here? We're adding 3. Oh, adding 3. So add 3 every time. Okay, let's say we have, let's go 120. Okay, so it's pretty easy also. Okay, you should be able to tell me the next two like right away. 80 and 70. What's happening every time? Goes down by 10. Okay, we subtract 10. These two patterns are linear patterns. Okay, because when something is a linear, it changes by the same amount every time. And the thing that it changes by is the slope. This is the slope of this set of, this is called the sequence. This is the slope of this. The slope of this guy is -10. Those are linear patterns because they add and subtract the same amount every time. Okay, now take a look at this one. No, that's wrong. Shoot. We'll go 2, 6, 18. There we go. That'll do it. Okay, should be able to find me the next two. Please and thank you. Okay, what's the next one, Owen?
54.
54. And the next one?
162.
Nice. What's the pattern here? We multiply by 3. Okay, which you should be able to be like, hey, I can add 4, right? I could add 4 to get to that, but I didn't add 4 to get here. So if I'm looking for the same pattern every time, it's a multiplication. Okay. So let's see. When we have, this is what we want to talk about. If we have a linear pattern, or a linear function adds or subtracts by the same amount every time. Okay, that AMT is abbreviation for amount. A linear function adds or subtracts by the same amount every time. An exponential function, well, also let's put this on here. A linear function, what's this graph look like? If it's linear, what's the graph of a linear equation look like? It's not right. This is not a rocket science question. It's not a trick question either. Oh, you guys, you're hurting my heart here. If I said to you, let's graph y equals 2x plus 1, you know how to do that. What's it going to look like? Thank you. It looks like a straight line. Okay, so a linear function adds or subtracts by the same amount every time, and its graph is a straight line. An exponential function multiplies by the same amount every time. Okay, and we'll talk about its shape a little more. He has a curved shape though. Okay, we'll talk about his shape momentarily, maybe tomorrow. Okay. So notice that linear adds or subtracts. Exponential multiplies. What does it not say? If this is adds or subtracts, this one you would think would say multiply and divide, and it does not. Okay, so important thing, we do not divide. Okay, we do not divide. So here's what we're going to do. Let's say we have this table here. Or switch our tables in this direction. They're easier to write. 0, 1, 2, 3, 2, 4, 6, 8. X and Y. 0, 1, 2, 3, 4, 8, 16, 32. Okay, so write those down, please and thank you. And the question that I have is each of these guys up here, linear or exponential? Linear or exponential? So this first guy, is he linear or is he exponential? How do we know? Yeah, because what are we doing every time? We are adding 2. So linear, and you would say because we're adding 2 every time. So when you take the quiz on this, it's a question, there are questions just like this on the quiz. It will say, is this linear or is it exponential? And it will say why. Okay, so it's linear because it's adding the same number every time. So don't forget that you have to answer the why when we have that. Okay, this guy, linear or exponential? Ooh, 50-50. Okay, so if it's linear, then it would be, what's the pattern right here? Okay, am I adding the same amount though?
No.
How much did I add here? 4. If I were to add 4 to 8, I would get 12, and that's not what's here. So it's not linear, it's exponential. Okay, Because what are we doing? You said what we're doing. We're doubling, but what that means we're multiplying by what? Times 2, right? So we're multiplying by 2 every time. So this is exponential because we're multiplying by the same number every time. So when we take a quiz, this is how you need to answer the why. Okay? You can't just say I'm multiplying every time, because that doesn't mean you're multiplying by the same number every time. You're going to be really specific about it. Okay, we're going to try another one. Just a second. No! I thought I waited long enough. There you go. Oh, satisfied?
Yeah.
Okay. Okay, so let's try this. Here's a pair of these. So again, I'd like to know, is it linear or is it exponential? 2, 3, and 0, 1, 2, 3. We're gonna do 3 of them actually. Okay. Okay, same question. Linear or exponential? I actually got 3 of them.
Can we not divide?
Correct. You cannot divide. It's a good question. Oh, so that's why we're talking about it. Okay, first one. Linear or exponential? Linear. How do we know? Subtracts by 2 every time. Adding, subtracting, linear. Now, the middle one. Like, you want to say it's exponential, but you can't multiply, right? It's not neither. So let me say this. I want you to listen carefully to this. I know it's almost time to go, but Elijah, you should turn around and listen. I am multiplying there. What am I multiplying by? No, not multiplying by negative. Nope. What'd you say, Raina? 0.5. Multiplying by a half. So we'll finish right there tomorrow, or we'll pick up right there tomorrow. And I'll remind you of that.